Hello there, ICS2O folks. We've got a lesson today on file handling, and of course, whenever we're using computers, we're always handling files, opening files, and closing files. But what we're talking about today is your programs opening files and closing files. So this idea here is often we want to keep some data from our programs for later, either as output or input. So sometimes we'll want our program to write some stuff not to the screen but to a file, so then we can check it out later or save it for another time that we run the program, or for input. So for instance, a good example is, you know how long when you run your program it takes to type in things from the keyboard? Well, wouldn't it be faster if all that stuff was read in automatically or quickly from a file? And in fact, whenever you're loading up a program and it says loading, 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 it's probably accessing whatever program you're opening, games, whatever, a bunch of different files where stuff has been saved from the last time you used the program. And that's the idea that we're dealing with today. And Turing, it's not that hard at all. A little bit of new stuff, and we'll see that we can output data to a file pretty easily, and later we'll be inputting data from a file pretty easily. So there's the first command, and it looks pretty intimidating, but I'm going to go through the pieces. Open is the magic word for dealing with files. You need an open command, and notice the colon there. Almost every single file handling thing in Turing's got a colon there. And then stream number, file name, put. Notice the commas where they go, and I'm going to explain what these pieces mean. Stream number is an integer variable, so it's whatever it has to be a variable, and the idea is when Turing successfully opens the file, it assigns an integer value to stream number here, and we can choose any variable we want. It opens a data stream, and Turing refers to that file with that integer variable stream number. We saw something very similar when we handled images, right? When we loaded an image, it assigned an integer value to that image, and then we referred to the image with its variable name, stream number or image number or whatever we called. The second part, in quotes, is a file name, usually a text file that shows up in the default Turing directory. So wherever you saved your Turing programs, that's where this text file will end up being dumped. Okay, and we'll see that in action in a moment. And the comma put, the put part means that this file will be for output. Instead of putting to the screen, we're going to put it to this file. And that's what this thing says here. Put tells us what the open file will be used for. It's for output. A few other things, and these are important but sort of less necessary, I suppose. The command assert stream number or whatever integer variable is hooked up with our file is greater than 0. Make sure the file opened okay, or else the program will quit. So this is a way for Turing to sort of check its files to make sure everything's in order before it continues with the program. Otherwise, it'll shut down right there. We actually output to the file with put colon, then the file number, the integer variable, and then whatever we want to output. Whether this is a message or variables or whatever we want to output, this stuff will get written to the file. And we can do that in a loop. We could do that a whole bunch of times, a bunch of put statements, some calculations, and then some put statements, whatever we'd like to do. And at the end, usually we close the file. So close, colon, and then the stream number will close that file. What's nice is if we forget to do that, Turing kind of does that for us, and we don't have to worry about it. So, all right, well, let's give this a go. Fire up Turing. I think hopefully you'll be able to read this okay. So my first command was, and I'm going to see if I can get them both going at the same time here so I can make sure I don't goof up my my syntax. I know it's getting small for you, but you've got your note there somewhere. So here's my my first try at output to a file. And you're typing along as well, so you have some sample code, both in our note. We're going to copy this into our note, and we're going to save this as well, so we have some sample code. Open, and then I'm gonna call it file one. This could be anything we wanted to, and then I'm going to call it my first file .txt. The dot whatever doesn't really matter, except for when we'll see when I put this in, run the program, and it outputs to that file. If it's a .txt and I double click on it, it'll open in Notepad, and I kind of like that. And I want to have it for output, so I put put. Notice right now, file 1 has not been declared, so I've got to use var file 1 as an integer, remember. And then what am I going to do? I'm going to, first thing, I'm going to use my assert statement. Assert file 1 is greater than 0. So this is the idea, was Turing able to open this file for output? And we hope so, but that assert statement makes sure. So and I'm just going to go put, for the first time, to the file, put to file 1, that's the stream number, and I'm just going to put hello world. And then at the end, oops, I'm going to close my file. Close file 1. I'm going to run that. Oh, I'm going to save it first. File, save as. Where is this? I'm just going to put up my desktop here. I'm going to call it, what am I going to call it? My first, maybe I'll just call it output to file. Output to file. That saved that, and now I'm going to run it. And hopefully that worked. It says output to file finished execution. Let's check the old desktop or wherever you had it. I don't know what that was. My first file. Hello world. There it is. It's in, and notice that it opened in Notepad, and there's hello world. Now I'm going to add a little more complexity because this is pretty boring. What I'm going to do is I'm going to do a little loop, and I'm going to loop and have read some stuff from the keyboard and then print it out to a file. So I'm going to have here some input, which is going to be a string, and I'm going to say put enter some stuff and stop to quit, and then I'm going to have a little prompt there. Stay on the same line with the double dots. Get input, and then I'm going to put out to my file whatever was input. But before that, I'm going to exit when input equals stop. Okay? And then all that looks good. And whoops, I needed an end loop there. End loop. Let's see. Does everything look good? Indent. Let's save that again. Run it. Enter some stuff and stop to quit. So, hello world. My name is... Oh, something weird happened there. We're going to have to think about that in a second. Third, stop. All right, so let's see if that actually worked. Notice this was actually open, but let's see if it wrote it. Yeah, hello world, my name is Ferd. It did that. What happened here, and we've seen this a few times in Turing, is when I use the get statement, when I use the get input statement, it'll only get one word at a time. And so it got the first one when I entered, let's see here, when I entered my, it did that, and then name is a different one, but it outputted the prompt 3 times. So what we actually probably wanted to do is get a whole line of input. So that's that colon star gets a whole line of input. All right, and that's going to work. Okay, that's going to work. Save that. I can copy and paste that. I'm just going to snapshot that. You can copy and paste it into your note. There's my example. So I'm going to snapshot that. Whammo. Dandy. My first try at an output to a file. There it is. If I wanted to, I could snapshot what my file looks like too. Why not? In Notepad. Make that a little smaller. There's my file, and I know it worked. Okay, dandy. So that's outputting to a file, and you can, see all sorts of applications for this, like keeping a person's score on your game, or saving yourself the hassle of typing in a bunch of stuff. You could save it to a file, and saving to a file, of course, in your program is only nice unless you can read data back from the file, like a high score list, right? If you have a high score list, you got to get the old scores back in, don't you? And so we'll pick that up in part 2 of the video.